Continue from the previous example, we gradually to build, we have few function, but at the end we have the classified function. So by passing the table and the example, you want to find the prediction and how many near its neighbor you want to check. So they will return the predicted class, or we can say that's the predicted label based on how many near its neighbor you want to use. Then we also try to see, we check couple points. For example, we're using the 21 and the 10th row and the 15th row to check if our prediction is correct. So yeah, we can do one by one, but also after we do our case near its neighbor, we will ask, which K will be the best? Is the bigger the better? Or is we have other choice? So that's why after we build up our classifier, we also need to evaluate our result. So that's why here we will do the evaluation. So the evaluation, of course, that's the accuracy we want to check for our classifier. So in order to find the accuracy of the classifier on a labeled data set, we need to find the proportion of the examples that are labeled correctly. And also remember from last lecture, we already say, we got our sample data from our population. So actually we will have some portion, most of the time we're using the bigger portion to train our classifier. So then we use the rest of that to do the testing. So this testing actually can help us to get the accuracy for the classifier. So that's why in order to get the accuracy, we need to compare the classifier prediction to the true labels. That's why we keep a portion for the test set, because we already know what is the true label. If the label data set is sampled at random from a population, then we can infer the accuracy on that population. So we see the example, just like the example we use at the beginning for the breast cancer patient. So let's use that example to see how we get it, how accurate our classifier is. Okay, so the first thing we will run again our patient. We got the number of row. Also, like earlier, we say they almost have 700. Okay, so then we will use some proportion to use for the training set. Then we use the rest of that for our testing to see we call that test set. So then we can see the accuracy. Okay, so then you can see here, actually, instead of just raw, we use our patient table. That's resample our patient table. But this one, our sample is, we have the with replacement equal to false. So on the other hand, actually, we're still using exactly the same data, the same number amount of time. But one thing is we kind of just rearrange the order, just in case the original table, they have specific order. So that's why we call the new table, we call that a shuffled. Okay, so they just random permute on the row, but all the row, they only exactly show once because we have with replacement equal to false. So then we're using our training set. So after we shuffle, we just take the first half. Okay, then the rest of the other half we use for our test set. Also in this example, we just use 50-50. But sometimes people use 80-20. So then all depends on you. Okay, but here we're just using the 50-50 for example. Okay, so then after we have our training set and our test set, so that's get our accuracy. So the same thing. Yeah, you just passing on your table. Okay, so then that's our, so then you have two sets, right? You have training set, you have your test set. Then just let me know how the input K is how many the nearest neighbor you want to include. Okay, so then so since the table we didn't drop the class, so then here in our test set, Okay, then we drop the class. The reason here we drop the class column is just because each row we still need to call the classify function. Remember, in the classify function, we pass in our training table. Then we tell them which row we want to check to predict. So then our K. Okay, so that's why here we just drop the class first. But later, of course, we need to use the class from our test set to see is that correctly predicted or not. Okay, so then we have the number of correct equal to 0. Okay, so here then we just need to go through all the tests, each row from our test. So then we use the for loop. Okay, so then you can see we have all the total number of rows from our test set. So you can see here it's a little different, right? We use I, we didn't use the row. The reason here we use the I, we didn't use the row is because to call the classifier function is fine. But one thing is when we try to see if our prediction is correct or wrong, we need to get the specific order from the class column. So from here, we need to pass in the index for the item. So that's the reason we didn't use the row in our for loop. We need to use the index I. Okay, so that's the reason. Okay, so then here, so after we got the C is our prediction, we pass in our row. Okay, so then here we have our training set. Since our training set is not overlap with the row, so that's why we just pass in the training table. Okay, so then you will see that's our prediction. Okay, so we just need to see our prediction C is the same as our the index I, the ith row the result for the class. If that's, so here actually they just say true or false, right? So if that's true, actually it's 1. So that's we just plus 1 will increment. So at the end, we just see the total correction divided by the total row for our test. Okay, so here, yeah, so then we can try. Okay, so here actually we just call this evaluate accuracy. We pass in our training set, our test set. So we have our K equal to 5. Okay, so you can see here we have exactly we pass in the training set and the test set. Okay, so here we pass in K equal to 5, equal to 3, equal to 11, equal to 1. So I just run again because I just want you to show you, see, actually it take a little time. Because remember, you need to find each example, then all the distance to all the training set. So this one, actually, we will see the answer earlier. We say, how to choose the K? Is the K bigger, the better, or not? Okay, so you can see here, accuracy for K equal to 5 is almost 97. So equal to 3 actually is more than 97. Okay, so then your the 11 actually, yeah, it's the highest one, is 97.3. Actually, even you just passing 1, that's the nearest neighbor. They are almost 96% as well. So in this result, right, so K is bigger, actually is better. But one thing is, the reality actually is not. Actually, the K is really depends on the question itself, on the test itself, the model itself, the data itself. So that's why that's wrong again. Okay, because like earlier we see, right, since we shuffle the data, so that's why supposedly every time you run, okay, the result actually supposedly will be a little different. Yeah, okay, yeah, but this one, right, they are still have the K is bigger, that's better. Yeah, but one thing is, actually you can run, so I just want you guys compare your result as well. But one thing is, the K actually is not the bigger is the better. Okay, so that's all depends on the situation. But one thing is, we can see here is, you can see no matter 5, 3, 11, or 1, all the K we use is odd number. Okay, so does anyone know why we use the odd number? Yeah, discuss with your classmate. Yeah, So the reason actually just because remember the result we want to get our prediction is who got the majority vote. So we make the odd number, just make sure it's not they don't have two options, they are tied. Now, so make sure you run through and also you can try. So maybe here, let's try 13. Okay, so we just want to see if this one, yeah, supposedly, yeah, it's not, the bigger is the better. Okay, but one thing is we just try to run again. Or we can do, yeah, later we do 9 if we still have nothing. Yeah, but one thing is make sure you also run on your side to make sure then the result. Oh, that's interesting. Actually, you see the 11 and 13, they are exactly the same. Oh, okay, sorry. Yeah, supposedly I should start running from beginning. Yeah, because one thing is if I only start running again from here, because they don't shuffle. Okay, so that's why if we want to check again, actually we need to shuffle again. Okay, so let's do it again for everything. Okay, so make sure you run through everything. So then you see your result, compare your result with your classmate. Okay, so then we see, okay, you can see here, actually that's what I said earlier, I didn't shuffle again. So that's why you see your data here. If we see this one, actually the highest accuracy is, yeah, they are all 96 something. You see here, even 13 is smaller than 1. Okay, so actually this one, the highest one is k equal to 3. So that's why your accuracy actually, k is bigger doesn't mean they will be more accurate. It just depends on the data. Okay, so that's our accuracy for our classifier. Okay, before we finish this lecture, so we just have 2 things we want to give you the heads up. Be careful about when you do the classification. So before classifying, okay, so here is the example. We use the image. Okay, so we want to have an application user provide the image. We can tell them that's dog or wolf. Okay, so that's why you can see here we have 2 picture. So that is both are wolf. So we told them, so that's what we train our model, we train our classifier. So we provide many picture image about the wolf. Then we have the dog. So we just say, for example, we only have 2 pictures for wolf and 2 pictures for dog. So then we have 1 picture here. We have a dog on the snow. Okay, so you guess what the result will be. So very possibly because the data we have in our we train our classifier, we have both wolf is on the snow, and also this dog, we didn't give maybe enough face of the dog. So possibly the application will tell you actually this one is a wolf. So what does that mean? That means when we say we train our classifier, you provide your training data, right? Be careful, the diversity is very important when you provide your test data. So here we say in the examples, but that means the training data. So make sure you have enough example, the diversity about your example when you train your classifier. So they have enough knowledge to identify, to predict the class you specify. Okay, so that's one thing you need to be careful about that. And also one thing is start with a representative sample. So that's earlier we say. Both the training and test set must accurately represent the population on which you use for your classifier. Okay, so like earlier we say, you need to be more diversity. So if your overfitting happen when a classifier does very well on the training set but cannot do as well as the test set. So that's earlier we say. You see, you have all the wolf, you are all only on the snow. So that's why when they see even that's a wolf on the grass or a wolf dog on the snow, they cannot really identify well, predict well your test set. Okay. And also, in our last lecture example, chronic kidney disease data set. Okay, so standardize is necessary if your data may be too big. Also, then if your attributes are on very different numerical scale, also very big, the distance can be affected. Okay, so that means if we really want to include from our example, last lecture example, the chronic kidney, if we want to have all the attribute we want to include, but you can see here, the glucose is only less than 400. Okay, so then hemoglobin is very small. Then the white blood cell count is it's multiple thousand or more than 10,000. So those attributes, they are really on different numeric scales. So when you have the distance, the bigger number will kind of have too much weight on that. So in this situation, it's better idea we convert all the variable to the standard unit. So then they will close to between like -3 to 3. So everyone has, because according to your average, so according to the standard deviation, so all the standard unit will be in a smaller range. So when you have the distance to include all the attributes, they will have even weight on that. So that's our classifier. So then actually that's our last lecture week. So your homework assignment 12 will be your last homework assignment. And this week we only have one homework assignment. So then the next lecture, lecture 37, will be our last lecture. Then next week we only have 2 case study examples. So then module 15 you will have your the last project. Okay, so that's our lecture 36 classifier.